So today we're going to deal with another homogeneous equation such that it follows this, and it seems simple enough because it's just one nth derivative to the fourth derivative actually, and this is just the 0th derivative. So it seems very simple, but however it gets more complex, you have to the fourth derivative, which deals with square roots of I, square rooting square roots of I, and then plus or minuses all over the place. So I want to try to simplify it by using Euler's equation and show you a more elegant way of doing this, I think. So, here we go. We're going to start off by writing the characteristic equation. So 16r to the fourth plus 625 equals 0. And we can solve that pretty simply by subtracting, then dividing. So, get r to the fourth. And we get to the point where we have to use the fourth root, and I mean this is pretty nice when it simplifies, but the -1 kind of gets weird. So we're going to use Euler's equation quite simply to solve this. And Euler's equation allows me to write -1 to equal e to the I pi. That's just a result of Euler's formula, which is kind of cool. And since this is like a -1 in front of the 625, we could have put this e to the I pi into this equation. So r to the fourth equals e to the I pi times 625 over 16. Now we could take the fourth root of this. So we do r. Since this is the fourth root and it's a positive exponent, we have to include the plus or minus because we don't know what term multiplies to get this number or this number. So we do this. We go plus or minus, I guess I'll put brackets, e to the I pi over 4, and then the fourth root of this is quite simply 5 over 2. So you got that now. Now, I have to convert this to a more manageable complex number. I mean, I can't solve for I in the exponent pretty easily because then you have to do ln, and just not nice. So I'm going to use Euler's equation to convert back to an equation that deals with cosine and sine. So I could write e to the I pi over 4 simply as cosine pi over 4. Pi over 4 comes from this part, plus or minus I sine pi over 4. And these two are equal. Alright, so what I can do now, I could plug this into this equation right here. So this is where it gets kind of weird because you got plus or minuses everywhere. So we're going to do this, cosine pi over 4. I realize you could simplify this. I'm going to do that after this. Alright, so cosine pi over 4 is simply just square root 2 over 2. Remember from your trig identities. And we could find it. So that is simply square root 2 over 2 plus or minus, I forgot that minus there, I square root 2 over 2. Now I'm gonna move this up here so we could work with something manageable. So I'm gonna do I'm gonna distribute this into here. Ignore the plus or minus. I'm just gonna do regular multiplication. So here we go. We're gonna do r equals plus or minus, then we're going to do that, 5 square root 2 over 4 plus or minus I 5 square root 2 over 4. Now it's a very nice compact equation for the roots. So now we can write a complementary solution. So basically the negative goes here, positive goes here. You get this complex thing. You get 4 different solutions, or 4 different roots, which satisfies the amount of nth derivatives, in this case 4, because you need 4 roots for 4 derivatives, so there's a theorem in mathematics about that. But you could find this equation quite simply. So we could write our complementary solution like this: yc of x, complementary solution, which is also the general solution, as I'm gonna probably need more space, but here we go. E to the 5 square root 2 over 4x times sine, or cosine, doesn't matter which one, times a constant 5 square root 2 over 4x plus c2, another constant, cosine of 5 square root 2 over 4x. And then we're going to add one more term because there's a negative in front of this. There's also a negative in front of this term. So we get a negative 5 square root 2 over 4x times c3 sine 5 square root 2 over 4x. And then you add that to c4 cosine 5 square root 2. Am I off screen? I'm sorry about that. Over 4x, and you multiply that whole thing. That's your general solution. You get 4 terms for 4 derivatives. And I wanted to show this because if you do square roots of i's and square roots of that, it gets really ugly. So I thought this was a more compact way of doing it. Just writing this and putting this here, and then doing all this stuff, and then writing a more compact solution. So if you guys have any homework questions, please email me or send me a comment or anything, and I could probably solve your homework problem before your homework is due. See you next time.